Hi everybody, Scott Stanchfield here. Let's talk about the room abstraction for databases in Android. To start with, this is some really simplistic object persistence. Don't think of this as a normal object relational mapping or ORM. This is really one object equals one row in a database, and that's pretty much all you're doing with it. They're looking into some more complex relationships and things, but think about it as every object just represents a row in a database and a story. You have an abstraction on top of that to help you create the database and help you actually map data, but it's not as complex as a typical ORM. You set this up using some annotations on your classes. You're going to have a couple different types of classes, entities, data access objects, and databases. And your data access object can either return objects, which would be a synchronous call. Basically, you're talking to the database and you wait until the data has been retrieved. Generally not a good idea unless you're doing that from a background thread. Or you ask the database for a live data, it hands you the live data, which acts like a bucket. You can go ahead and do whatever you want in the meantime. Once the data has actually been fetched, he'll drop that data in that bucket. You just observe the live data, and when it's ready, you do your job. There's some very limited support for automatic relationships. These would be one-to-many relationships. We'll take a look at that, but in general, it's a little easier to do some other things rather than using this automatic relationship. To start with, you need to add a couple dependencies. First of all, we're still going to use our view model and live data dependencies. Typically, you're going to use the lifecycle extensions version that you're going to bring in. And then we're going to add a couple new dependencies down here. Note that in order for this to work, we need to apply the Kotlin KAPT plugin. KAPT stands for the Kotlin Annotation Processing Tool. In Java, there was already a tool called APT, the Annotation Processing Tool. They just made a Kotlin version that'll actually read Kotlin code and Java code instead of just Java code. Just a little note here, if you're using KAPT, you should always use KAPT as the type of dependency, as opposed to annotation processor, which is what you would use for Java. So if you have a mix, just use KAPT and it'll cover the whole thing. There are two dependencies we have here. One is an actual runtime library you're going to need for compilation in your library and actually at runtime. And this is the Android X Room runtime library. As of the point that I'm recording this, it's 220 RC01. That's a release candidate. For KAPT, this is saying where the actual annotation processor exists. So they have something they call the room compiler. This guy at build time is going to take a look at all your classes. Any classes that are annotated with room annotations, he will generate the appropriate code to hook those up to the database. The types of components that you're going to deal with, there's three of them. First of all, entities. And these are going to look like normal classes. In this case, I'd say entity, class, person, entity. And I'm defining an ID and a name inside there. Now, you can use a normal class like this. You can use a class that defines the properties in the constructor, or you can define a data class for it, depending on what you want to do with the data. A data access object is responsible for retrieving data and updating data in the database. To do that, you either define an interface or an abstract class. It has to be some kind of an abstract thing, either an abstract class or an interface, because when the room compiler takes a look at this, it's going to create an implementation or a subclass of it. You add this DAO annotation in front so that room will be able to recognize it. Each of your methods in here will have a query, insert, delete, or update annotation on it to tell room what to generate behind the scenes. And these are all abstract methods that I have here. Later we'll talk about some non-abstract methods, but generally in the DAO, most of your methods are abstract. The query methods are the ones that are going to run some squeal statement. And if you haven't heard me say it before, squeal is the proper pronunciation of SQL. I learned that at IBM, and IBM is always right. The reason behind it was that squeal is one syllable versus SQL is three syllables or SQL is two syllables. So squeal wins. Unfortunately, every time you say squeal, you have to describe it to everybody, and then that takes up more time. So it's kind of a lose the first time. But throughout the rest of the course, I'm going to save a ton of time just by saying squeal. So there. So anyway, inside of this guy, we have queries. That'll be just some squeal you want to execute. Insert is saying this is going to be an insertion method. Delete, it's going to be a deletion method. And you can also have update methods. Note that this vararg here is optional. If you want, you can say vararg people. Vararg in Kotlin means it's a varying length argument list. So you can have any number of people passed into this insert statement. If you didn't have vararg listed, the insert would expect exactly one person every single time. Similar for delete and update. One little note here. If you wanted to have a specialized query for a deletion, for example, maybe you wanted to completely wipe out a table. Instead of using delete annotation, you'd use a query annotation and just say delete from the table name. Now the table name you specify is exactly the same as the actual entity class. So in this case, my entity class is person entity. I just use person entity as the table name. The database just kind of collects all of these things together. First of all, you pass in a list of entities to the database annotation. So here we have person entity : class. This is a Kotlin class instance, so it's going to tell it that this is just metadata about a person entity. You can have any number of entities, comma separated, and then you specify a version number. One thing to note, if you modify your database, so in other words, you change your entity definitions in any way, if the version number hasn't changed, you'll get an exception saying that it couldn't verify the integrity of the database. So anytime you change your entities, you need to change your version or completely reinstall the application. To start with, as you're developing, you're probably good just keeping the version number the same and then uninstalling the app and reinstalling it. When you're in production, you're going to want to set up some code to actually do database migrations. Not going to get to that into this class. You can take a look online and find information about how to do migrations using Room. They're working on some ways to actually make that a little bit easier, but for the time being, it's basically dropping tables, recreating tables, or copying data into new tables that you created and deleting the old ones. It's a bit manual. In this database, he extends Room database and has abstract methods for getting instances of the DAO. Now keep in mind, these DAOs, it doesn't have to be a one-to-one relationship between a DAO and an entity. You could, if you want, have a separate DAO for each type of entity. For the example I'm doing in this class, I'm just going to have a movies DAO, which covers all three entities that we're going to be putting in the database. On your entities, we'll get a little more detailed here. If you have a computed field or some field that you for some reason don't want to put into the database, you can just throw an add ignore tag on it. And then that way you won't get a column for it and it won't copy data in or out. If you need an index, so if you want to improve your performance, for example, we could say, hey, I'm going to be looking up by first name and last name very commonly. So let me create an index on them. And that will let us, when we do a select using first name and last name in our where clause, it can find our data much faster. When defining your entity, you can also define how it relates to other classes. We can set up a foreign key definition, which is going to say how an address in this example relates to a person entity. So in this particular case, I'm going to say that a person can have multiple addresses. That's a one-to-many relationship. Whenever you have a one-to-many relationship, the easiest way to set that up is in the thing that is the many, you would have the ID of the one. So the ID in person entity maps to person ID in each of the address entities. We further specify that using this foreign key definition, saying that the parent column for the person entity is ID, child column is person ID, so we know that relationship. And then we specify what to do whenever things are updated or deleted. In this particular example, I chose to say that whenever we update the person entity, so maybe we change his ID, we want to make sure we propagate that down to the address entity and fix these person IDs. So we'll say on update is foreign key cascade. We cascade from the person entity down through the address entities. On delete, we're going to do something similar. In this particular example, we're going to say that an address is owned by a person entity and the address should never exist on its own. Therefore, if the person gets deleted, we want to delete the address. In that particular case, we're going to say on delete is foreign key cascade, meaning if the parent is deleted, delete the child as well. We can also set up embedded fields, and this you wouldn't do in the actual entity object. You do this in a plain old Java object. We'll see some examples of that a little bit later. But what this lets you do is when you're running a query from the DAO, if the query specifies columns from address entity, it can fill those in and just create an address entity object as opposed to having to have separate fields for each of those things that were pulled from the database. We'll see some examples of that later. If you want to do any name mapping, and this is most useful if you have a pre-existing schema where the database already exists and you're trying to set Room up on top of it, You can just add a column info to say, instead of calling this name, we're calling it person name in the database. And maybe the table here for the entity is person. If you're having Room create the database for you, these are really not needed. Most of the time, they just get in the way and cause a little confusion. But if you're trying to map to existing data, this is a good way to go. In your DAOs, your query methods can have parameters coming into them. So if we take a look here, we have select star from person entity where ID equals :ID. Note that this :ID here matches the ID as a parameter coming in. Any parameters coming in, you can specify just using colons. So this ID without a colon is the ID in the person entity database. So that's the ID column in the person entity. When we run one of these queries, let's take a look at what happens. So select star from person entity. That's going to give us all the data, all the rows. Each row is going to be mapped to a person entity object, and we're going to return a list of that. Now we can either return just the list directly or wrap it in a live data. In this particular example, since we say it's a live data, the caller can call get all, immediately get the live data, and the database behind the scenes is going to start running a background thread to load all those people. Once he's loaded all the people, he'll drop them into the live data, and if we're observing it, we get notification. So your typical pattern on this is you'll call get all, immediately put an observer on it, and then go and proceed to do something else. Once that observer is triggered, you know that the people have been loaded from the database. Now, sometimes what you may want to try is on an insert, just go ahead and use an insert regardless if you know the person's in the database or not. If you try to insert a person that exists, you'll normally get an exception. If you put an on-conflict resolution strategy here to saying replace, what it'll end up doing is delete the existing person and then create a new person, insert the new person in its place. That's nice unless you happen to be using a foreign key. Like if we go back a couple slides here where we set up this foreign key, where we say person entity has these addresses, if we had this type of a definition, and then in our DAO, we had an insert with a conflict strategy replace, the combination of those two is pretty deadly. What's going to end up happening is that this person entity gets deleted first of all, which is going to cascade down to delete all his address entities. And then, whoops, wrong place. And then replace it with the new person. Now, if you really want to wipe out all his addresses, this is great. If you don't, I strongly recommend you implement a update separately and do not put on conflict strategy replace. So in general, if you ever use a cascade delete, do not use on conflict strategy replace with it. So the question you get is, when do I return a live data from a DAO or not? Places you'll want to return a live data. If you want to have updates when a database is updated, and this is actually a really, really great benefit of this. If you say, give me a live data, like let's take a look at, oh, I had them right here. There we go. Let's say we have get all. We have live data list person entity. Behind the scenes, the database sets up a trigger that anytime a new person has been saved or a person has been saved or a person's been inserted or deleted, that list will be updated. So all you have to do is call this get all once. You get a live data, you observe it. You can use that to fill out data in a recycler view, put it in some other kind of list on the screen. And anytime you add or remove a person, that automatically gets updated. That's a great benefit of this guy. If you need to make your call from a user interface thread, this is your only choice. If you try to actually do a database update or database synchronous query from the user interface thread, you're going to get an exception saying you're not allowed to do that on the main thread. There are ways around that. I strongly recommend you don't do it because sometimes database access can take a little while. Now, another place where this is really helpful is in a transformation switch map. Again, note that null doesn't work properly in transformation switch map. Take a look at the live data module and then that fix that I had for the switch map there. But this sets it up so that you can say anytime one live data changes, go to the database, get the live data for whatever data you needed to load from the database, and it'll get filled in when it needs to. That way you don't have to set up any threading or anything like that. It's really convenient. Now, if you're already working in a background thread, then returning an object itself for any of the queries is really a good way to go because, hey, you're in the background, you can just go ahead and get things and work with them directly in line rather than having to set up a chain of observers. If you ever find yourself setting up a chain of observers to say while you're actually trying to process something, probably not a good idea. You only want your chain of observers set up in your view model or when you initialize your activity or fragment. You don't want to have a function that says, let me create a bunch of observers and then remove a bunch of observers. I've seen people do that, and it's a real mess. Let the database take care of you. So in a case like this, you can kick off a background thread, make some direct calls, get the data back. You'll basically block until the data is ready, and then run other queries, and that works great. That's really what I'm talking here when I say database updates trigger another live data. So if you have a chain of these guys going, but you need to have all the data worked on at once, you're really best working with the objects itself. Also, if you want to make sure that things are in a single transaction, like maybe you're doing a movement of money from one account to another in a bank, something like that, you want to happen in a single transaction so that if something fails, you don't end up with more money in some place or less money in some place than should be there. There is a little relation annotation that you can use. I don't recommend you use this, but just to mention how it works. First of all, I want to try to get a person and his addresses at the same time. So instead of saying get a person and then trigger a separate request to go and get the addresses, maybe I want to get them all at once. To do that, I'm going to have the result of get person and addresses be a list of person name and address. This is a special class that I'm creating that's just a normal POJO, a plain old Java object, or in this case, a POCO, a plain old Kotlin object. And this one does not have an entity tag on it. What this has is just holders for all the data that we want. So we have an ID and a name as holders. So these would be for ID and name for the person. And then a list of his addresses to read in. And we set this relation up here saying it's a one person to many addresses relationship. The parent column is ID. That's the ID here that we see in person name and address. And the entity column is person ID. In each one of these address entities, we're going to look for a person ID that matches this ID up here. Now, what ends up happening is this ends up triggering two separate queries in Room. First of all, the queries to get the persons, so all the people. And then for each of those people, we're running another query to get the addresses. It's actually more than two queries. It's n+1 queries. So we get all the people, then we run to get all these address entities. So it's a little on the expensive side, but it's something that you can set up to kind of simulate some ORM, object relational mapping type functionality. Don't recommend you do this. I'm going to show you another alternative to this when we go through the example. If you want to have multiple things happen during a function call in the DAO methods themselves do not need to be abstract. And a good example of this is if we assume we had a bank DAO and there's a couple bank accounts and we want to actually move money between bank accounts. So we're doing a transfer. This function here is not abstract. Fund transfer is saying I'm taking in two accounts and I have an amount that I'm going to move between them. So I'm going to do account one balance minus equals, account two balance plus equals, and then do inserts or updates on these guys. Again, depending on how you have those set up. So if you have foreign keys set up, you probably don't want to use the insert, you probably want to use the update. By marking this with a transaction, the database starts a transaction before it does all this. So if at any point something fails, nothing actually ends up happening. If instead you did this through some logic in your code and you did the changes, inserted the first one, but the second one failed for some reason, then you're going to have a bad balance between those two accounts. So money could get created or destroyed. Probably not a good idea. When you're accessing the database, be careful if you're currently running inside the user interface thread or if you're running on a background thread. So here's a couple little examples. Let's say that we define an executor here. This guy is going to be running some code on a background thread. So there's one thread that he reserves. Anytime you say executor.execute, he runs the code on that thread. We're going to create our database here. So Room Database Builder, setting him up. And then if we ran something in a background thread, db person DAO insert person, this code here, because it's actually modifying the database, has to run in the background. So you have to have it in that executor.execute. If you put this code in something that's run on the user interface thread, you're going to get an exception out of that. If you want to do something on the user interface thread, here's an example of using a asynchronous get all. This get all query looks like this guy right here. is returning a live data with the list. When you call it, you immediately get the live data back. The database starts a background thread. Once it's fetched the data, it drops it in the live data, and you'll hear about it if you're observing it. So if we take a look here, here's an example of how you'd normally use this. Val live data is db person DAO get all. So now we have a live data. Note that at this point in time, the value may or may not actually be available. So if I immediately after this live data said live data.value, I have no way of knowing if that's actually the data that's been retrieved or not. Maybe the timing just worked out, the database happened to be finished with it, maybe not. So instead of looking at live data.value directly after you do that, set up an observer. So we're going to say live data observe, passing in the lifecycle owner, which will probably be an activity or fragment, and then the what to do when that changes. So once the database tells us it's actually done, he'll drop the data in the live data, trigger our observer, we'll look at it and say, okay, if the data is not null, let me go ahead and put out the person's name.